I know, explanation as to why it was there. So I was like, I don't know.
Huh. Okay. Interesting. Well, anyway.
All right. Well, the broadcast has started, so do you want to go over or start the quiz?
Yeah.
Sure. Let's do it.
All right, let me bring it up.
Same here.
13 questions.
Okay, find the margin of error for a 90% confidence interval with the standard deviation of this. Let's just run to 3 decimal places. So the margin is equal to z-score times, hold on a second. So we have the z-score times the standard deviation of the square root of the n. Okay. % confidence.
Or sometimes my applet doesn't work.
So we're supposed to find the margin of the error first, right? Or calculate that and then put it into the applet for 90%.
Yeah, I've been trying to put it into the applet, but my applet won't work.
Yeah, hang on.
Okay, so the z-score. So what do I highlight for 90?
5.
I think you just do the middle.
Okay, so I get the z-score to be 0, 1, or 0.16. No, that can't be right, is it? No, never mind. It's 1.645 being the z-score for 90% or whatever.
So when we, hold on a second, we have 90%.
Wait, what did you get?
For the z-score for 90%, I got 1.645.
That's oh.
So we're calculating the z-score, so we have the x minus the mean over the standard deviation, right?
I think this one is different, maybe.
Huh?
I'm not sure what the formula is.
Well, we're supposed to calculate it's x minus mean. X is a score over the standard deviation to find the z-score, I guess. But what's the x in this formula? Is it 90%? The margin of error for a 90% confidential interval.
Yeah, so I think it's just a standard deviation over the square root of oh wait, what is it? I'm sorry.
The square root of n.
Yeah, and then you multiply it by the z-score. Yeah, so it's the z-score, so it's 1 point, let me see, it's 1.645 multiplied by the standard deviation, which is 50 divided by the square root of n.
So that's just times 10.
Yeah.
The square root of 25 is 5. 50 divided by 5 is 10.
Yeah.
So then it's 1.645 multiplied by 10.
How'd you get z? What's z?
So if you put 0.90 into the applet up at the area part of it, then
Okay.
give you the corresponding z-score. Does that make sense?
Oh, okay, that makes sense. So I have 1.1.
So it's 1.645 multiplied by
10.
10. Yeah, okay.
Okay.
So it's 16.45. Is that what it is? I don't know. What did you get, David?
I got 16.45.
Yeah, that's what I got. 16.45.
Decimal places.
Well, 0.450 because you have to round to 3 decimal places.
Okay.
16.450.
Okay.
Yeah.
Okay. So we're on to the next question then. 4.
Mm-hmm.
Yeah. Okay.
Point estimate.
Collect a simple random sample of n equals 64.
Oh, the point estimate.
Yeah, x.
So that's like you have like the
Oh, isn't the point
you
estimate
take the
or whatever?
Point estimate
So I think the point
formula.
estimate is 526.
yeah. Yeah.
So x equals the point estimate?
Yeah, because it's it's basically whatever the mean is.
Okay.
So that's the sample mean, and because there's more, they took a large sample. We presume that it is close to the mean.
Okay.
Where the population mean is, that's what the point of estimation is.
Okay.
Does that make sense?
Yeah.
Something like that, anyway. If not, that's close.
No, yeah, it's basically the mean.
Okay.
Okay, now I need to find the margin of error, 95% confident or confidence interval.
The very same way that we did the other one.
So it's the square root of
X minus
16.
413 over 1 over the square root of n. Is it?
My applet like works about half of the time.
No.
Did anybody get the z-score for 94?
Z-score for
It's
what?
1 point for 0.95.
Oh.
Yeah.
It's 1.96.
1.96, is that what you said?
1.96
It's just 1.96
times
by 113.
over the square root of 64, which is 8.
Why won't my applet work? So did everyone get the answer?
So 113 divided by times 1.6. 1.96. I got 27.685.
That's what I got.
Yeah. What was it again?
27.685.
Oops. 27. I like forgot my calculator, so I'm trying to like do this in Excel. 27.865. Okay.
Mm-hmm. And I guess to get the lower limit of that, which is next.
The lower limit is not where
Yeah,
you
so,
highlight the left.
Isn't that x minus m?
yeah,
No.
so the lower and higher limits, you just subtract or add the margin of error to the point estimate.
Mm-hmm. So we have our z, which is 27.6. So I have 27.685, and then we have what was it again? X is so 526 minus 27.685.
Mm-hmm.
So we have 526 minus 27.685.
Wait, it was 27.635, wasn't it?
It was 27.685 was our
Okay.
number, right? Our
I wrote it the opposite way around. I just wanted to make sure I had it right.
margin of error. I got what the number I got was 498.315.
That's what I got.
Mm-hmm. 498 point.
315.
Yeah.
0.315.
And then the upper limit we just add.
Add. So 526 plus 27. 6, 8.
Did I get
553.
553.685?
That's what I got. 553.685.
Okay.
685.
Are you good on that, David?
Yeah, I got.
Yeah.
Are I gonna me?
No. You're Donnelly, right?
Yeah, right.
Okay. Sorry.
Okay.
Okay. What would happen to the width of the confidence level or confidence interval if Gina increased the sample size?
It would decrease.
Yeah.
Mm-hmm. Yeah, that makes sense.
What would happen to the width of the confidence level if Gina changed to 90%? Wouldn't it increase?
Yeah.
Okay.
So we'll have to work it backwards for number.
Oh, yeah.
And
Bright light bulb company is buying a study.
Oh, how do you do this?
$400. 95% confidence level. Error margin of $50. So we have a margin error. So we have 50 is equal to C times. Well, we have. Okay, I need to open up the applet again.
Is it 95%?
Yeah. What did you guys get for the 95% for the z-score?
1.96.
And how again do you get that? I put it into the normal probability applet, and I got something different.
Yeah, I don't know.
Are
Mine's
you
been acting weird too. So
are you putting it at the in the
At,
box at the top?
yeah.
And are you highlighting it in the middle?
Okay. Let me. Okay. What'd you get then? I'll highlight that in the middle and then 0.95. Okay, so is it 1.96 is what you got?
Yeah.
Okay, never mind, I got it now. 1.96 is the z-score, so it's 50 is equal to 1.96 times, let me see the question again. So we have it over 400 divided by 400. So what we're trying to find is the margin. Oh wait. Okay. So 50 is equal to 1.96 times 400 over the square root of n. So what we're trying to find is n in this question?
Yeah.
Okay.
is the confidence interval the same as the standard deviation? Is this another way of saying it?
No.
Or I mean, margin of error. That's different, is it?
400 times 1.96. 50 is equal to 784 over the square root of n. Over 4 is equal to
You know how big the population is now?
So he wants the margin of error to be 50, right?
Mm-hmm.
I don't remember how to do this one.
784
I'm just gonna open the book.
is equal to 1.
Oh, okay. So it's the z-score multiplied by the standard deviation over the power, or divided by margin of error, and all of that is squared.
I'm trying to figure out 50 divided by 784 is equal to 1 over the square root of n. And I'm trying to figure out what n equals.
Oh, we don't have the n.
Okay, I got it. So if you look at 13 on the preparation assignment in part 2, the answer key has the formula that you do. So you do the z-score times the standard deviation divided by the margin of error, and then you square that.
Yeah.
Did you already say that or do that?
Yeah, that's what I had.
Oh, wow. That makes it a lot easier. I was trying to do like reverse algebra, like all this algebra and stuff.
Yeah. Yeah, no, I just found the formula, but I didn't figure it out yet.
Oh.
Well, that makes life easier. So I got 784 over 50 squared.
Yeah. So I got 246.
Just let me compute.
Yeah, because we round up to the closest one, don't we?
Yeah, you have to round up.
Yeah, I get 246.
Yeah, I have 246, 245.86, but for rounding up to the nearest number.
Okay, 246.
Number,
So.
Oh, 246. Okay.
Ready to move on to the next one?
Yeah. Mean salary is this, and the standard deviation is this. You're interested to know what the mean salary is actually worth. I've already set up a hypothesis.
So don't we work this out just like the other one we did?
The lower limit, so this is 1.96. What's the lower limit of the confidence level? Okay, so we have x minus the z-score, which is 1.96 times, I have to look at the standard deviation over n, okay, which is 36.730 over the square root of 36, which is 6, okay. Now we have 1, 1, 1, 0, 0, 0.
What did we say the z-score was?
If it's a 1.96 again, isn't it?
Yeah, if it's 1.
It's 95. It's 95%, right?
Sure.
Well,
yeah. I think you're right.
Yeah, yeah, it is.
Sorry, I just said that because I was like looking at. I was reading something while I was answering you.
3, 0, 0, and then divided by 6 is that. So minus 1, 1. Hello, almost done. Huh?
Are you done in groups?
Yeah. Yeah, I'm almost done. So I got 111,000 minus 11.99846.
Wait, 11.998?
Mm-hmm. Yeah, isn't it 1.96 times 36.7 divided by the square root of 36, which is 6?
Yeah, so I mean I just got 11,998, not 11.998.
Maybe I'm looking at the wrong. That's because that's because I put 36.3730. Whoops.
That's how they get you.
Yeah, 96.
So what did you get the answer to be?
So 36,000. Okay, now I have 11,998.466, and then you subtract that from. Okay. So 1, 1, 1. So overall, I got 99001.53.
Yeah. Oh, round to the nearest whole number.
So 99002.
Yeah, what I get. 99002.
Yes. And now the upper limit, so we just add that number instead.
Mm-hmm.
So 111,000. This 11 point. Wait.
Everyone there? Did everyone get it, or are we still working on it?
Well, I got 122,998.466, which ultimately rounds up to 122,999.
998.
Well, if you round up 0.46, 6 rounds up 4 to 5, and 5 rounds up 8 to 9, right?
Oh,
Does it work like that, or no?
no, yeah, you're right.
So it's 12998. Is that what we're saying?
I thought it was 122,999.
Oh,
Yeah.
I keep writing these down wrong.
Well, if you round, it says I got 122,998.46667, and if we round up, doesn't that round up to 122,999?
122,999. The answer previous to this was 99,002,
Yes,
and this is 122,999.
I believe so. What do you guys think? Do we round it up if it's 0.466?
Huh.
Because,
Just don't.
well,
Because like I just looked at like 0.46 and I was like, oh, it's below 0.5, so round down. But yeah, if you do it one at a time.
yeah, 0.6 is rounding up 0.4 to 0.5, and 0.5 rounds up to 0.9. I mean, rounds 8 to
Yes.
9.
I guess I'm gonna put 9.
I'm going to put 9
And-
because that's what I think it's supposed to be. But I could be wrong.
1, 2, 2, 9. That's what we're gonna put.
Sure.
At least if we're wrong, we'll be all wrong together.
It's not very comforting because it would be my fault.
That's okay. That's
Well, let's find out.
All right. The 3 requirements needed to check the computing a confidence interval for the mean. They are.
That's all the above.
Yes.
all right. Let's submit.
Oh boy, I'm a little nervous. Hey, we got it.
Anyway,
We got it.
okay, good job.
Sweet.
Nice.
Okay. Well, I'll see everyone on Thursday. Does Thursday still work for you, Donnelly?
Yeah, it does.